An engineer is working in mountainous terrain. She needs to know the distance between two locations E and F which are inaccessible across a deep gorge. So here are the locations E and F. She finds two locations C and D on her side of the gorge which are on the same level such that the distance between C and D is 20 meters. Using a theodolite, she finds the measure of four angles as follows. Angle ECF is 48 degrees. Angle FCD is 57 degrees. Angle CDE is 63 degrees. Angle EDF is 50 degrees. Use this information to find the distance between E and F. First, let's look at triangle ECD. We have two angles in it. We're given two angles, and we have the distance, of course, between C and D, so we have two angles on one side. 57 and 48 is 105 degrees. So we can find the third angle in triangle ECD. This angle is 12 degrees. The three angles, of course, add up to 180 degrees. What I will do is I will start by finding the side CE of the triangle CED. So we're looking for this side, so I will call this little a. If we're looking for a side, we use small letter a. So if we call this small a, then capital A is 63 degrees. Now we need a side and a corresponding angle. Well, the only side we have is this side here, which is 20 meters, so we call this small b. The angle that is opposite small b is capital B. That's up here. So we have the sine rule, and we need to find small a, so we multiply across by sine a. So we fill in all the values. Small b is 20. Capital A is 63 degrees. Capital B is 12 degrees. Working this out to two decimal places, we get 85.71, and this is in meters. Now let's look at triangle FCD. We have two angles in it. This angle here, which is 57 degrees, and this angle here, which is 50 plus 63. That's 113 degrees. We are going to get the distance of C to F next. We'll call this distance A. Call what we're looking for A. We're looking for a side, so we use small a. If this is small a, then capital A is 113 degrees. Now we need to use this side here. This is the only side we have, which is B. B is 20 meters, so this angle up here is capital B. This angle is opposite this side. So we have a similar situation to before. So let's get capital B. Well, it is 180 minus these two angles, shown in green here. These are the angles at the base of this triangle. So B is 10. So as before, we apply the sine rule to find A. So little b is 20. Capital A is 113 degrees. This is divided by the sine of B, which is 10 degrees. To two decimal places, we get 106.02 meters. Now let's look at the triangle ECF. We're interested in the distance between E and F. So, we're looking for a side. We label it small a. What is the angle opposite small a? It's down here. It's 48 degrees, so we call it capital A. And B and C are two sides of this triangle. So we have two sides and the angle in between, triangle ECF, and we're looking for the third side. Now, in a previous video I explained to you that we can't use that using the sine rule. We don't have enough information. We can't say A over sine A equals B over sine B because we don't have B. The only way we can solve triangle ECF is to use the cosine rule. So plugging all of this in, we get this value here. This is a squared. We want the square root of it. We put it to the power of a half. So to 2 decimal places, a is 80.16. The diagram below represents a simplified model of a bridge known as a cable-stayed bridge, where AE is the supporting tower and BC is the carriageway for traffic. Cable-stayed bridges are very convenient in conditions where there is no good access to the far bank, as they can be built from one side only. In this particular model, angle BAC is 90 degrees. So here is angle BAC. AE is 40 meters and the distance of B to C is 100 meters. If E is nearer to B than it is to C, use your knowledge of geometry to explain why there is only one location along BC for the tower AE in this model. Well, the reason is that the angle in a semicircle is 90 degrees. See, we are given that this angle here is 90 degrees. And we want our tower to be 40 meters high. So you can imagine constructing a circle with diameter of length 100 meters, distance of B to C. So there are only two positions for the tower. We can either have it here or we can have it over here, so that the height is 40 meters. So these are the only two positions, but we are given that E is nearer to B than E is to C. If E was nearer to C, the tower would be over here. So you can see there's only two positions, but possible, such that we have a right angle in a semicircle. This angle is an angle in a semicircle. It's 90 degrees. It stands on this arc here, which is 180 degrees. The angle at the arc is half the angle at the center. In part 2, we want to find the distance between B and E. Now, one way of doing this is to use a circle theorem. Here's what we do. We can show a complete circle here, and we draw in a chord of the circle from the point A down through E and extend it to hit the circle here. Now, the line BC is a diameter of this circle, and we know that a line drawn from the center of a circle perpendicular to the diameter, to the chord, will bisect the chord. So if this length is 40 meters, then this length down here is also 40 meters. Let's call the distance of B to E x. Then, since the distance of B to C is 100, the distance of E to C is 100 minus x. So, the theorem that we use, which I cover in another video, states that if we have two intersecting chords of a circle, then if we multiply this distance by this distance, we get the same answer when we multiply this distance by this distance here. So 40 by 40 is 40 squared, and that must equal x times 100 minus x. So we multiply out this, and we're going to get a quadratic equation. We have an x squared term and an x term, so we have to get 0 on one side. This thing has factors. The factors of 1600 that we need are minus 80 times minus 20. That gives plus 1600, and we will get minus 100x for the x term. So next step is put each factor equal to 0. So if we put x minus 80 equal to 0, we get x equals 80. Or for the other one, we get x equals 20. So x can either be 80 or 20. We can see from this diagram that it looks like x is 20. If x was 80, then the foot of the tower would be over here. And that was the other situation that we discussed earlier from the first part of the question. There are two positions for the tower, but we want the tower to be closer to B than to C. If the tower is over here, then this distance is 20, and x now is this distance, x is 80. But it's the other way around, of course. X is 20. Here is another method for finding the distance between B and E. We consider the two triangles ABE, this right angle triangle, and the bigger triangle ABC, which is also right angled, but the right angle is up here. So one angle is the same in both triangles. Actually, there is another angle that's the same, and that's this angle here. Two triangles overlap with angle ABE. So if two angles are the same, then the third angle by default is the same. The three angles add up to 180, so we're dealing with two similar triangles. And if two triangles are similar, it means that the sides are in proportion. We also have the length of AE here. We know that it's the height of the tower, which is 40 meters. I'm calling the third angle in both triangles x. Let's look at the cos of x in this triangle here. The cos of x is the side adjacent to x, which is 40, divided by the hypotenuse, which is AB. Now in this larger triangle, the cos of x is the side adjacent to x, which is AC, divided by the hypotenuse, which is 100. Of course, we have two unknowns in this equation, so we don't have enough information to solve it. However, since ABC is a right angled triangle, we can apply Pythagoras. So we know that AB squared plus AC squared equals 100 squared. So the longest side, or the hypotenuse of this triangle, is 100. Square the hypotenuse is the sum of the squares of the two shorter sides. So we can solve between these two equations to find AB or AC, and from that we can find what BE is. Well, if we find AB, we will have two sides of this shorter, smaller right angle triangle, and from using Pythagoras we can find BE. Now when I got cos x for both of these triangles, I got these two ratios. However, these two ratios can also be got from the following two ratios. 40 divided by AC equals AB divided by 100. Now these two ratios come from corresponding sides of similar triangles. So the side of length 40 is opposite this angle here, this dot, and if we divide it by the corresponding side in the other triangle, so we're dividing 40 by AC, and that must equal AB, which is opposite the right angle, divided by the corresponding side in the other triangle. So 40 over AC equals AB over 100. And we can rearrange this ratio to get these ratios here. We can actually divide both sides by AB and multiply both sides by AC, and we'll get this. So there are two ways you can arrive at this thing here. But of course you could just work with this. 40 times 100 is 4,000 equals AB times AC if we cross multiply here. So either of these two ratios will lead you to this equation here. And also we have, of course, Pythagoras. So we need to solve between these two equations to find out what AB is. So we need to try and eliminate AC. That's the quickest way to do this. Eliminate AC between these two equations. So I will rearrange this to make AC the subject. It's divided across by AB here. And we'll plug in for AC in this equation here. Now I'm just going to let y equal AB just for convenience. So we have, for AB squared, we have y squared plus AC squared. That's 4,000 divided by y squared, and we have 10,000 on the right hand side. So you see we get a quadratic equation in y. Now let's multiply across by y squared, because we're going to get a y squared in the denominator. Y squared times y squared is y to the power of 4. And y squared is a cancel here. We have 4,000 squared on top. That's 16 with 6 zeros. 16 million. And multiplying the right hand side by y squared gives us 10,000 y squared. So just multiply across by y squared. Now this is a quartic equation, but a quartic equation can be transformed into a quadratic equation. So we just let y squared equal x. So if y squared is x, then y to the power of 4 is got by squaring y squared. But that's just the same thing as squaring x. Okay, so y to the power of 4 is just x squared. And we have 16 million. And on the right hand side we have 10,000 y squared, where y squared is x. So now you see we have a quadratic equation in x, but we must keep in mind that x is y squared because we need to get y. So remember, y is ab. Okay, so we need to solve this equation, so we need to get it into standard form. We get the factors of 16 million. They are minus 8,000 and minus 2,000. These factors work out. So we get two solutions for x. So x, remember, is y squared. So y is got by getting the square root of x. So we have two solutions. Either y is the square root of 8,000 or y is the square root of 2,000. Remember, y is equal to ab. So let's go back to the diagram. So y is ab. So we can either have the square root of 2,000 or the square root of 8,000 for ab. Let's suppose that AB is the square root of 2,000. Well, how do we find BE? Well, we have a right angle triangle here, of course. So we see that BE is the square root of the hypotenuse squared. Well, if we square the hypotenuse, we get root 2,000 squared. That's 2,000 minus 40 squared. 40 squared is 1,600. So we have the square root of 400 here, which is 20, as we saw before. That's what we got before. Now the other solution is the square root of 8,000. So if we replace this value here with 8,000 and calculate BE, so we will be getting the square root of 6,400, which is 80. So just like before, we get two values for BE. BE is either 20 or 80. If BE is 80, as before, the tower is over here, closer to C than it is to B, and we don't want that. So we ignore this solution. So we find that AB is root 2,000, which means that BE is 20 meters. The 5 cables emanating from A meet the line BC at equal intervals of x meters at the points M, L, K, V and W. So this distance here is x, so is this. KV is x, and finally VC is x. If the tan of theta is 2, where theta is the angle which shortest cable AM makes with BC, find the value of x. Well, looking at the right angle triangle AEM, we can see that the tan of theta is the side opposite theta, which is 40, divided by the side adjacent to theta, which is EM. We can just interchange EM and tan theta to get EM equals 40 divided by tan theta. We are given that the tan of theta is 2. So we have 40 divided by 2, which is 20. As a matter of fact, this value of theta is the same as this angle here, because we look at this angle, the tan of theta is also 40 over 20. 40 divided by 20 is 2. But anyway, let's go and get x. Well, this last bit is easy. The distance of M to C is 100. The distance of B to C minus BM, which is 40. The distance of B to M is 40. So we have 100 minus 40, which is 60. So 60 equals 4x. So x equals 60 divided by 4, which is 15 meters.